If your one-size-fits-all prompt is doing support, summaries, and code help, routing will save you. We'll classify intents and send each request to a focused prompt, tool, or model. You get noisy answers and wasted tokens when one prompt tries to be everything. Routing fixes that by sending each request to the most appropriate specialist. By the end of this video, you will understand how to detect intent, pick a prompt, score routes, enforce cost or latency limits, and execute the best path in Python. I'm Professor Pi, teaching AI engineering and LLM systems from basics to advanced, with simple, concepts-first Python that helps you solve bigger real-world problems. Task routing solves a clear, practical problem. In a mixed workload, some queries need code reasoning. Others need short summaries. Some need external tools, like a calculator or a database lookup. A single, generic prompt often gives mediocre results and burns budget. Success looks like faster replies, fewer wrong answers, and lower compute cost. The router sits in front of your models and tools. It decides where each incoming request should go. At a high level, routing is classification plus decision logic. Imagine a query about debugging Python. You want a code model and a code-aware prompt. A billing question should go to a support prompt with canned policy text. The router inspects the query, labels it, and maps that label to candidate routes. Strengths include clear specialization and predictable cost. The trade-off is the extra engineering to detect intent and maintain templates. We will build a small Python router as a mental model. It will first detect intent with simple rules. Then it will pick a prompt template. Next, it will score candidate routes by a feature-driven formula. After that, it will filter by cost and latency constraints. Finally, it will execute the chosen route and return an answer. The concepts to know are intent, route, estimated cost, and latency budget. Now we start by classifying the request. First, we will classify the incoming request into an intent. This snippet classifies a query into an intent using simple rules. This snippet shows how the router checks the incoming text for keyword signals and shallow patterns. It begins by defining a small list of intents and associated trigger words. The code then lowercases the input and counts matches for each intent. It returns the top matching intent and a confidence score derived from the number of matches and query length. Key lines include the intent map, the loop that counts triggers, and the confidence threshold check. If confidence is low, the snippet marks the request as ambiguous, so the router can route to a safe fallback. Adjusting the confidence threshold moves more queries into fallback or into direct routing. Next, we will choose a specialized prompt template for that detected intent. This snippet selects a specialized prompt template for the detected intent. This snippet maps the detected intent to a prompt template and then fills a few template slots with the query and context. The core part is a template registry that holds short templates optimized for support, code, and summarization. The code picks the matching template by key and injects the user query plus any small context, such as recent messages. There is also a default template for unknown intents. A key knob is the number of examples embedded in a template. More examples usually raise quality, but also increase prompt length and cost. Now we will rank candidate routes using simple features. This snippet ranks routes by a simple feature-driven score. This snippet constructs a list of candidate routes for the same intent. A route is a combination of a prompt template, a model or tool adapter, and estimated cost and latency. The code computes features like intent match quality, estimated latency, and estimated cost. It then forms a weighted score as a linear combination of those features and sorts routes by score. Important lines include the feature extraction, the weight vector, and the final sort operation. Changing the weight on estimated cost versus intent match will send more queries to cheaper options. or to higher quality but costlier routes. Then we will filter for budget and latency requirements before picking one. This snippet chooses the best route under cost and latency constraints. This snippet takes the sorted routes and applies explicit constraints such as maximum allowed cost and a latency deadline. The code first filters out routes whose estimated cost exceeds the budget or whose latency exceeds the deadline. After filtering, it picks the top route I score. If no route fits the constraints, it falls back to a safe default route. The main parameters to tune here are the budget and the latency deadline. Tightening the budget forces cheaper routes and may sacrifice quality, while loosening it allows higher quality choices. Finally, we will execute the chosen route and return the final answer. This snippet executes the chosen route and returns a final answer. This snippet fills the selected prompt template with the query, invokes the chosen model or tool adapter, and performs minimal post-processing before returning the text. It includes a timeout and an error path that retries with a simpler route or returns a fallback message. Key parts are template rendering, the adapter call that dispatches to either a model or an external tool, and the post-processing steps such as stripping system tokens or merging tool outputs. If the adapter fails, the snippet shows how to fall back to a cheaper or safer route. In a production setting, you would wire this router behind an API endpoint and add logging of route choices and latencies. You would also collect labels so you can refine intent triggers and tune the scoring weights. Recap: it classifies intent, selects templates, scores and filters routes, then executes the winner. Use this when you have mixed workloads that benefit from specialization or when you need cost and latency control. One caveat is that routing adds overhead and needs monitoring to avoid misrouting. Next step, tune the routing score weights, especially the balance between intent match and estimated cost, and observe how that shifts route selection. If short, practical AI engineering helps, subscribe and watch the AI engineering videos.